Hello everybody and welcome back to AP Calculus Free Response Questions. This is free response question number 1 from the 2013 AP test, a rate in, rate out problem. Let's get started. So it says on a certain workday the rate in tons per hour at which unprocessed gravel arrives at a gravel processing plant is modeled by G of t equals 90 plus 45 cosine of t squared over 18, where t is measured in hours and 0 is less than or equal to t is less than or equal to 8. At the beginning of the workday, t equals 0, the plant has 500 tons of unprocessed gravel. During the hours of operation, 0 is less than t is less than 8, the plant processes gravel at a constant rate of 100 tons per hour. So, A tells us to find g prime of 5 and using correct units, interpret your answer in the context of the problem. Now, finding g prime of 5 is easy peasy. It's the interpreting the answer that a lot of students find pretty difficult. So let's start with g prime of 5. So, dg of dt of g of 5, if I plug that into my calculator, I'll get something like negative 24.587. Now remember, g of t is a rate in tons per hour. We've taken the derivative of this rate, so now the units are becoming tons per hour, or hours squared if you will. It's also negative, so we know that something is decreasing. Geez, my handwriting's pretty terrible. In this case, at t equals 5, the rate at which gravel arrives, because g of t is the rate in function, is decreasing because g of t is a negative by, and here we'll restate our number, 24.587 tons per hour squared. And this is our justification here. You'll notice that I didn't say negative 24.587 at the end because I already mentioned decreasing, and that would kind of be redundant. Moving right along, question B. Find the total amount of unprocessed gravel that arrives at the plant during the hours of operation on this workday. So basically, we're just having a simple integral here of the gravel that's arriving, which is g of t, during the workday from 0 to 8, t equals 0 to t equals 8. We're not going to include the initial amount the plant had because we only want the new stuff that's coming in. So this is simply the integral from 0 to 8 of g of t dt. And if you plug that into your calculator, it'll come out to something like 825.551 tons. Don't forget your units, that's an extra point at the end. Alright, question C. Is the amount of unprocessed gravel at the plant increasing or decreasing at time t equals 5 hours? Show the work that leads to your answer. Well, to do this, we're going to compare the rate at which gravel is being processed, the in rate, versus the rate at which it's going out at time t equals 5. So we're going to just evaluate g of 5 here. G is the rate at which gravel is coming in at time t equals 5. When you plug that into your calculator, you'll get 98.140 at t equals 5. And we know the rate of output at t equals 5 is constant. It's always going to be 100. So I'm just going to say output equals 100 tons per hour. So we're going to notice that g of 5, the rate at which it's being processed, is less than the rate the rate at which it's arriving, G of 5, is less than the rate at which it's being processed, the 100. So because it's being processed faster than it comes in, the amount of unprocessed gravel is decreasing. So yeah, the amount of unprocessed gravel is decreasing. Part D, what is the maximum amount of unprocessed gravel at the plant during the hours of operation on this workday, and justify your answer. This one is a doozy. But let's start by finding an equation for the amount of unprocessed gravel during zeros less than t's less than 8, and I'm going to call it U of t for unprocessed. So we can say that U of t is going to be equal to our initial amount of unprocessed gravel plus the integral from 0 to 8 of our rate in minus our rate out, which is just 100 constantly, dt. Alright, great. Now it says that we want to find the maximum amount, which basically means that I'm going to be finding the absolute maximum of U of t over time interval 0 is less than t is less than 8. And what do we need for that? A derivative and critical points. Now you'll notice that the equation U of t, 500 plus 0, 8 dt minus 100 dt, kind of looks like a second fundamental theorem problem, and it is. If I was to take u prime of t, I'd just basically be getting g of t minus 100. And that's pretty convenient for us, right? So I had to graph this and find the critical points of this, the roots, and I found one at t equals 4.92348. Cool. I noted that it was a local max because the graph of my derivative switched from positive to negative at this point. Okay, finally, thank heavens, we can evaluate this. Tables are really nice. So I'm going to set up a table with t on one side and a of t on the other. I'm going to include my endpoints in this, as well as the t I just found, to determine which of my points is going to be my absolute maximum. I got to evaluate it. 4, 3, 0, and 8. So I just put it into a of t, which is more calculator stuff, and we have 0, 500. These four numbers, 635.37612, and then 8525, and I just rounded it to 551. Alright, so we know that this, our t number, is the biggest, so this is our absolute maximum. If I wanted to restate this, I'm going to say that the max amount of unprocessed gravel during my workday, 0 T8 in tons, equals 635.376. Alright, peace.